This is the first session that we are about to do now. This is related to cloud computing. So this series of sessions that we are going to follow is to our objective is to complete the Azure Foundations course. So in order to touch the Azure basics, we have to have a good knowledge on basic cloud computing techniques. As the first step, what we have to do is we should know what is meant by cloud computing. So it says cloud computing is the on-demand delivery of IT resources over the internet. So you can say I highlighted the term pay as you go pricing. So as the word implies, it says you're only going to pay for what you're going to purchase. So you don't have any upfront costs and stuff. So the basic idea related to cloud computing is when you're about to turn a light on, so you simply want the light to work. You know you need electricity for that to happen, but you're not thinking how this electricity flows to the bulb, how the switch works. Those things you're not going to work. So what you expect is you're turning on the switch, the bulb should light up. So that's the one of the basic ideas of cloud computing. When you're about to host something, say you have a website, you're about to host this machine, host this resource somewhere. So you are not going to think about how I'm going to create my infrastructure, how should I make a server room, how about the security and stuff. So cloud computing, you are just renting someone else's computing. That's the basic idea of cloud computing. So it says instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as power, storage, and databases, and whatever you need. So these you can see these are the main cloud providers, the top players of cloud computing. It's Amazon Web Services, Azure, Oracle, Google, and these days you can see if you search for social media, different companies trying to play this role. So basically, in cloud computing, what you're doing is you are renting someone else's resource to do whatever you need, and you are only paying for the resources that you used. If we go to the next slide, this says responsibility of a cloud provider. So as I said, since we are renting from somewhere, we have a cloud provider, so there is a responsibility as well for the cloud provider because we are taking the service from him. So you can see this compute power, storage, networking, and analytics, these things. So these are the basics when it comes to cloud computing. I mean, the cloud provider should be responsible for these things. So when we're talking about this, I think you have heard a term called SLA, which is the service level agreement. Sometimes you can see when you're going to purchase some services, it says 99.9 SLA, 99.9999 SLA. So that means they are guaranteeing, they're giving us some kind of a rating, and they're showing us we are this much responsible when you are working with these resources. So that's so these are the responsibilities when it comes to a cloud provider, and these three are the major. I mean, when it comes to cloud computing, we can hear these three terms. When we go to the next slides, you can see the same three terms using different terminologies. So it says we have something called VM and a container and a serverless architecture. So when it comes to this virtual machine, it says it's like a computer. So it's like the laptop or the desktop that you're using. And you might have come across this term virtual machine when you're working with VMware and VirtualBox like software services. So this is something that we are responsible for maintaining the operating system, something like that. So when it comes to containers, it's similar to VM, but except they don't require a guest operating system. So when it comes to containers, we are not going to work with operating systems. We are not responsible for this operating system related stuff. And we have something called serverless. So there we are running our code, and we don't care what's the base hardware, what is the operating system, but we are running our particular logic in a serverless environment. So we are not thinking about configuring, maintaining, or creating any server related stuff. So if we go to the next slide, we have a graphical representation to show how this 3 works. So I'm going to the next slide. So here we have a question. So can you open that particular tab? So I'm going to release the question now. If anyone having issues with this tool that we are using, just log into this webox.app and you can type the meeting ID here. You can log in from your mobile as well. So our password is so I released the first question. So it's asking which of the following type of virtualization is also characteristic of cloud computing. So if you feel like you are going for the wrong answer, you can simply clear it and you can click another answer. Cloud is we are renting someone else's computer, so it has most of the, not most, I mean almost all the characteristics that we are using in our local on-premises environment, those contains in a cloud environment in a more efficient way. So it's asking, simply it's asking if they are providing services such as storage, application, CPU, or are they providing all of these services as well. So since I got 75% of the votes, I'm going to close the poll. So you can see 91% answered for this all of the above section, and 8%, I mean 1 vote came for this storage. So if we check the answer is all of the above. So cloud providers provide all the storage, application, CPU, all these options. It's not going to only provide the storage. So cloud is not something that we are going to store our data. So the person who voted for this answer, I think he's thinking about something like Google Cloud, I mean our Google Drive. So yes, Google Drive is a kind of a it's kind of a service given by a cloud provider, but it's not only meant for storages, I mean the cloud computing. So as I said, we are renting someone else's resource. Since we are using someone else's computer, it gives us all these options: storage, application, and CPU. So in the next slides, let's discuss one by one how they're going to give us storage, how this application, and CPU. So the correct answer is all of the above. So let's get back to the slide set. So here you can see we discussed virtual machines, containers, and serverless. This is the graphical representation how the each component works. So here you can see all 3 VM container serverless, we have something called physical hardware. So this is obviously we have to have physical hardware because we are dealing with machines. So we have the physical hardware layer, and we have something called host operating system, or for all 3 it's common. And here we have something called hypervisor, and here we have something called serverless runtime. So this hypervisor, let's talk about virtual machines. On top of the hypervisor, you can create any number of virtual machines. So with just forget about the cloud, let's think about in your local PC you are installing VMware Workstation or VirtualBox. So what you're going to do is you're creating a virtual machine. So inside this VMware software, they have something called hypervisor. So what you're going to do is, say your computer is a Windows-based computer, we're installing Windows 10. So on top of that, we are creating a virtual machine which runs, here we'll say which runs Linux, and here we can say which runs CentOS. So in the guest operating system. So we have something called in the virtual machine, we have virtual hardware and we have this guest OS. So on top of these OS, we have different applications. So what hypervisor does is, when we create a signal from this application. It's going to the guest operating system, and it's coming through this virtual hardware layer, and this hypervisor converts this particular signal to this in order to accept it by the host operating system. So this operating system can be a different can be from a different vendor, and here we have Linux. So here also we have the application running on top of Windows. It's going to this virtual hardware section. I mean, when we are creating this particular virtual machine, this physical hardware is going to replicate into this virtual hardware section, because we have to show that particular hardware segment in this virtual machine as its own hardware. So he's going to convert all the signals from this operating system to this host operating system, and finally it communicates with the physical hardware. So that's how these virtual machines works. So here, when it comes to the containers, we have the physical hardware layer, and we have host operating system, and we have something called container engine. So in this scenario, we don't have virtual hardware. So we are not dealing with any operating systems. So on top of the container, we can have different containers. So what here in this containers, what we have to do is, when we are setting up a container, we have to tell this is my host operating system. So on top of that, we can run different containers which supports by this host operating system. And we have finally this serverless model. Again, there also we have a host OS, and we have something called serverless runtime. These are the benefits. So someone can raise a question why we are going for these cloud computing things. I can set up my own data center. I can host these things in my own PC. So these are some of the benefits of cloud computing. So if we go through this one by one, so it says cost effective. So why are we saying that it is cost effective? It's because when we are setting up an infrastructure, for an example, you are trying to start a new software company, and you think, for my clients, I'm going to host these software that I'm going to build in my PC. So why it says it's cost effective in hosting in cloud than installing and storing those in your environment. So it says no upfront costs. So when it comes to when you want to build your own data center, you have to create a building, you have to take these hardware, you have to create security mechanisms, you have to set up these lightning controllers and stuff, you have to set up cameras, because you have to protect your hardware. So you will have this infrastructure cost. So when it comes to cloud computing, you don't need to worry about these upfront costs. It says no need to purchase and manage costly infrastructure that you may use to its fullest. For an example, you are taking a machine which is 32 GB RAM, but in the first year you are not using that 32 GB. You might only use 8 GB. So even though you are not using it to the fullest, you have to purchase you have to spend money for this RAM store, random access memory, that's particular storage. But when it comes to cloud computing, we are not going to purchase the whole 32 GB. We are only going to pay for the amount that we are going to spend. Ability to pay for additional resources only when they are needed. So this is a very important property in cloud computing. For an example, your application. So tonight you're going to, for an example, you're hosting a e-commerce application. So you're going to sell a product which has a huge demand these days. So suddenly your website traffic increases. So your 32 GB RAM is not going to enough. So what are you going to do? So in that case, your server is going to burn up. So if you are maintaining your own hardware, own data center, you can't plug in another RAM. It will take a huge cost, and you have to turn off the machine. There will be a downtime. But in cloud environment, you can create a rule. If my application utilizes more than 80% of my RAM, you can spawn for additional resources from the cloud. So you don't have to touch any of these hardware to do these things. the ability to stop paying for resources. Say you're purchasing the random access memory. Now, once the demand goes away, you don't need this 32 GB, you don't need those 64 GB RAM memory. But if you are purchasing it, you have to take it with you. You have to keep it with you. You can't release it from your budget. But in cloud computing, you can simply release the unwanted resources. And finally, this cost predictability. So this cost effectiveness is one of the main advantages that we are having when we are compared with this on-premises data center. And I'll show you how this cost predictability works. So this screenshot is from Azure. They have a module called Azure Pricing Calculator, and this is from AWS. You can simply select, so here what I'm going to do is I'm going to create a virtual machine. It says 3.5 GB RAM, 50 GB disk. What is the region? What is the operating system? So it says I'm going to use this virtual machine for this amount of hours, and he's telling us this is the cost that we're going to get. So this is an approximated cost. Same thing in AWS, they have something called TCO calculator. So this cost predictability feature is there in the cloud environment. So if you are thinking you are getting a high traffic to your website in the next month, you can simply calculate the cost for the next month, and you can take the necessary decisions. But if you're dealing with on-premises data center, if you have your own data center with you, you can't do this. I mean, you can do this, but it's not effective. So the next property is about scalability. So when we are dealing with clouds, we have two terms called vertical scaling and horizontal scaling. So this, when it comes to this resources, when it comes to resource allocation, it's there we have some options where if suddenly if a huge load comes, what to do. So here you can see in this image, we have a virtual machine. So if you are still not familiar with this term virtual machine, think that you have rented a PC from a cloud provider and you have a set of specifications. Say you have 64 GB here. So suddenly this load, you're getting huge traffic, and this 64 GB is not enough to handle all the requests. So what you can do is there is a term called scalability. That means you can scale your machine. You can reduce and increase and reduce the size of your machine based on the requests that you are getting and based on the conditions that you have set. So it says vertical scaling, also known as scaling up, is the process of adding resources to increase the power of an existing server. So we have this 64 GB PC. So if you create a rule called, if I'm exceeding this particular threshold, if this request count is more than 80%, or if the RAM usage is more than 80%, just scale up or do a vertical scaling. So it will increase the CPUs and it will add more memory to this particular machine. So there is another term called scale out, which is the horizontal scaling. What it does is, is going to clone this particular virtual machine to different machines. So you will have for an example, in this scenario, say you are getting 64 GB here, and you're setting a rule saying that if the RAM is exceeding 80%, RAM usage is exceeding 80%, clone another instance. So this acts as an internal load balancer, and is going to pass the other load to this particular virtual machine. So here this 64 is there, and the other request that is going to consume from this particular virtual machine. If this is going to burn up, he's going to create another instance, is going to pass the request to the other virtual machine. So this is scale out. So the main advantage here is, once the request count is going down and the RAM usage is going down, you can simply delete this created resource. So there also you have to set it up saying deallocate this resource once the job completes. So you can simply delete the created virtual machine. But think, if you are facing this situation in your own data center, in your own server machine, how can you do this? So you're thinking, now my business has a huge demand, so it's okay to have two PCs. So you're creating another PC, you're purchasing one. Suddenly your demand losses, but what you're going to do with the other PC? You can't even use it. I mean, no point of using it because you can handle the other request using one single machine. So this is one of the main advantages, scalability, when it comes to cloud computing. And another term is security. So this is, so you can ask, I'm passing my data to a different cloud which is located in a different country, so how we are going to ensure the security? So cloud providers solve this problem in two different ways. One thing is they have a different cloud model for this thing, and another thing is they have something called these regions. And when it comes to data center security, they have invested huge amounts, so it's unbreakable. So when a person or a hacking attempt, it's very rarely happens in a cloud data center. If that happens, you have other means to protect your data from this uh, data breaching hacking techniques. So for an example here, I'll show you. This is from Azure. So Azure has something called regions, and inside a region you have something called availability zone. Geographically, physically dislocated availability zones are there. Once you push your data to here, either you can set it up to only place in this particular location, or you can simply create a rule, just replicate my data to this particular location as well. Or you can say, move my data, just create a copy to this location as well. Suddenly, if something happens to this particular availability zone, if the availability zone fails due to a earthquake or something, so physically this data center is going to destroy, but your data is still there because the same exact clone is in a different availability zone. Say a huge disaster happens to this particular whole region, still you can replicate your data, the region 2 located in America or somewhere, which is the geographical distance is very high. So in that case, still your data is safe in a different region. But you might have a question like, for an example, this sensitive data, if you really don't want to move your data to a different country, still you want to, if you still you want to keep those data in machine, there is a mechanism. So we'll discuss about that in the next slides. If we go to the next one, here we are coming for the second question. So please take your devices. So you can see the next question. It's asking which term from the list below would be viewed as benefits of using cloud services. So it's asking unpredictable costs, elasticity, and it says local reach only. Yeah, we got 86% voted for this thing, so I'm going to close the poll. So you can see, yeah, 100% answers are for this elasticity, though the answer is correct. We don't have any unpredictable costs because they are providing their cost calculate applications, so you can predict your cost. It's not only for local reach. Benefit is the elasticity. As we discussed, you can scale up and scale down your machine based on your desire. So we have another question there. It's asking, what is the term? Is the process of adding more servers that functions together as a one unit. Scale up, scale out, scale through, and scale add. So I got 15 out of 30. I got 13 answers. Yeah, I'm going to close the session. You can see 46% 1.5. The same amount of answers came to scale up and scale out. And there's no term called scale through, and there's nothing called scale add. So the answer should go between scale up and scale out. So the answer is scale out. It's not scale up. Even though you think about this word, you up, adding more services, it's scale out. So scale, if we go back to this session, it says scale out. So it's asking adding more servers. So it says adding more servers that functions together, that scale out. scaling up means for the same server we are increasing resources. So the answer is scale out. So scale through and scale add, there's nothing called scale through and scale add. I just added those answers. Capital expenditure and operational expenditure. So in the past, companies needed to acquire physical premises to physical premises and infrastructure to start their business. So before this cloud concepts comes, they have to rent or buy a building. They have to set up all these PCs. So it says capital expenditure is the spending of money on a physical infrastructure upfront. So even before you use your data center, even before you install your software, you have to spend this some amount of money. So that is meant by this capital expenditure. So then deducting that expense from your tax bill over time. So it says CapEx is upfront cost, which has a value that reduces over time. But once this cloud computing comes, there's this term came here, this operational expenditure. So these are the two approaches to invest, two approaches of investment that we can refer. So when you are working with the cloud, mostly you are getting this expenditure. It is spending money on services or products now and being billed for them now. You can deduct this expense from your tax bill in the same year. There's no upfront cost. So you are creating a virtual machine in Azure when you are installing something. At the time you are purchasing, you don't get any cost. To reach your billing period, you're getting a bill but that bill is just for this setting up cost and the service usage that you did inside that particular virtual machine. So that's the operational cost. For the usage, you are spending some money. The capital expenditure is you are spending upfront cost even before you start consuming your resources that you're about to deploy. So these are two other terms that when it comes to cloud computing, capital expenditure and the operational expenditure. So, and the next section is we have something called cloud deployment models. We have three types. One thing is a public cloud. So here you can see in the public cloud, most common deployment model is this one. In this case, you have no local hardware to manage or keep up to date. You don't have to update the operating system. I'm sorry, not the operating system. You don't have to update it to the latest hardwares and stuff. Everything runs on your cloud provider's hardware. So you don't get any hardware related failures. If you get it, it's cloud vendor's responsibility. So you're not going to manage these hardware related stuff. But in some cases, you can save additional costs by sharing computational resources. So this line is going to offer by different cloud vendors where you can purchase a public cloud. You're not going to manage this hardware related stuff. So you can see in this section, it says highly flexible and stuff. So the next cloud deployment model we have is a private cloud. So in a private cloud, you create a cloud environment in your own data center and provide self-service access to computational resources. So either this can be an intranet or you can connect it through internet. So this private cloud, most of these private clouds, we're using these VPN softwares to connect. So it says this offers a simulation of a public cloud to users, but you remain completely responsible for the purchase and maintenance of the hardware. So you are not going to take anything from these public vendors, but you have your own hardware, you have your own software, you have your own operating system. However, the external users feel like they are connecting to a public cloud because they are connecting through internet. So that's the idea of a private cloud. So apart from these two, we have another thing called hybrid cloud. So this solution, you have part of your application in a public cloud and you have part of your application in a private cloud. So this is the place where if your customer says, I want my database to be reside inside my PC, inside my server, but you can host your application anywhere you want. So that's where the hybrid cloud concept came. So here in this on-premises, you can keep your databases, you can keep your sensitive data. In the public cloud, you can host your applications, you can do all the load balancing, scaling. Whenever you want to access a data segment, you can create a tunnel between these two. You are getting the data segment from this on-premises cloud, on-premises data warehouse that you're having, and you're sending it to the cloud. So in that case, your application resides inside the public cloud, but your database is in the on-premises data center. So if you want to do something like this is also possible. So it says you could host a website in the public cloud and link it to a highly secure database hosted in your private cloud. And this is the most important topics in these cloud services, where you have something called IaaS, PaaS, and SaaS. So it's infrastructure as a service, platform as a service, and software as a service. So it's similar to the first image that I showed you, where I showed you something called virtual machines, containers, and serverless. So virtual machines comes under infrastructure as a service, and this containers comes under platform as a service, and this cloud functions or serverless computing comes under this software as a service section. So in the IaaS, we go to, yeah, let's have this question before coming to this particular section. So can you again open the app? So this question is based on this private, public, and hybrid clouds. So it's asking, suppose you have two types of applications: legacy applications that require specialized mainframe hardware and newer applications that can run on a commodity hardware. Which cloud deployment model would be best for you? So when we say legacy applications require specialized mainframe hardware, that means you have to build up the hardware segments there in order to run your application. I mean, that program to run on a specific hardware, which might not be commercially available or which is already outdated. So that's why we are calling those legacy applications. In this case, we need a hybrid cloud. So where what you can do is you can push these newer applications to the public cloud, and you can connect this, you can run the legacy things in your private cloud. If you need to interconnect these two, you can simply create a tunnel between these two to communicate. But that some components are running in the local environment, which is in this on legacy applications in the mainframe hardware, and the newer set is running on the public cloud. So you can't alter, as I said, you can't alter the hardware segments which is in the cloud. It's totally up to this cloud vendor. We were in this slide. So infrastructure as a service, it says the most flexible category of cloud services. It gives you the most control over the provided hardware. So it says virtual machines, storage, and operating systems. If you are going for this infrastructure as a service, you are getting the opportunity to install the application. You can install the operating system. You can select what operating system you need. You can simply you can handle the operating system elements. I mean, you have access to the services, registry, and stuff, except the hardware layer. So that's why it says you have the most control over the provided hardware. For an example, your application needs to access the operating system's core functions. So in that case, you have to have the authority to control those functions. So in that case, the best option is to go with IaaS, infrastructure as a service. So which is like you simply bought a machine from a different vendor. Once you log into the portal, you can simply RDC to a different machine. So you can get the look and feel of a normal computer that you're running in your local environment. So it says instead of buying hardware with IaaS, you can rent it. It's an instant computing infrastructure, provision and manage over the internet. So you're going to manage all the things through the internet. You have to have internet connection, otherwise you can't work with cloud stuff. So that's the IaaS. So if you go to this platform as a service, here you're not going to, you won't get the opportunity to do stuff with this and operating system. You can't hold the operating system. So it says it provides an environment for building, testing, and deploying software applications. So it says the goal of PaaS is to create an application quickly without managing underlying infrastructure. And finally, you have this SaaS thing, software as a service, which is centrally hosted and managed for the end consumer. So you can see the examples: Office 365, Skype, Dynamic CRM. So you're using Office 365. What you're going to do is you're simply opening the browser, going to online Word document. You don't care about on which operating system this software runs. So you don't care about anything, but the only thing you care about is the software that runs on top of this. So those things runs as software as a service. So that's the basic idea behind IaaS, PaaS, and SaaS. And this is the overview. You can see when it comes to on-premises, you manage all the stuff: networking, storage, servers, virtualization, operating system, everything. When it comes to infrastructure as a service, you start managing from this particular layer. So if you get updates from Microsoft, definitely, you have to install it. No one, cloud provider is not going to install that for you. If it's platform as a service, you think about your data, runtime, middleware, OS. You're not going to care about these things. That's why I said when you are selecting a particular platform, you have to select what's the runtime, whether the runtime is Node.js or whether the runtime is .NET or whatever. So you care about your data. You are the person who's going to paste whatever the things to be hosted. So data and applications you have to care about. When it comes to SaaS, you're not going to care about any of these things. We are just using the software as a service. So these are the main three things: IaaS, PaaS, and SaaS. You can see the question. It's asking, you're developing an application and you want to focus on building, testing, and deploying. You don't want to worry about managing the underlying hardware or software. So what is suitable? Which cloud provider type is best for you? What is suitable, which is best for you? So you can see the answers. So 8 answers for this PaaS and 2 for IaaS and 2 for SaaS. So the answer is platform as a service. So why it's not infrastructure as a service is, yes, you can build, test, and deploy in infrastructure and service as well, but it's asking what's the best for you. So in that case, since if you use IaaS, you have to manage the operating system stuff as well. So it's not the best for me. So if you really want to focus only on building, testing, and deploying, platform as a service is the option. So infrastructure as a service, you can do this stuff, but it's not the best if you are focusing on these three. So if you go to the next question, it's asking something provides virtual machines, virtual storage, virtual infrastructure, and other hardware assets. Is it IaaS, PaaS, SaaS, or all the above? So I have an issue there. It's going to 50-50. But the correct answer is IaaS. Please drop me a message if you have any issues with this question. Only infrastructure as a service provides us virtual machines. Virtual storage and virtual infrastructure, all these three options are given by this infrastructure as a service, IaaS. Because when we talk about virtual machines, we're getting this opportunity to manage the operating system software. So that comes under IaaS. So you can't say all the above, because simply from this term you can select infrastructure as a service. If I go to the next question, so we have 10 questions. We are in the 7th question. Cloud computing shifts capital expenditure into what expenditure? We talk about two types of expenditures: capital expenditure and another term where capital expenditure is there. You're going to face for these upfront costs, and the other type is going for this cost that we are going to pay for this for the usage. So there I got 14 responses. So yes, answer is first one. It says operating, operational, both the terms are correct. So the person who clicked this none of the above is thinking about operational expenditure. Yes, operational is also operating. It's not service. There's nothing called service expenditure. We have only two terms, capital expenditure and operational expenditure. Operational equals operating. So let's go to the next one. Which of the following can be considered as a PaaS offering? So this question is mostly if you have developed with one of these components, it will be easier to answer. I mean, without having this theoretical knowledge on LaaS, PaaS and SaaS, it won't be enough for this question. These are the answers. So actually the Gmail, it's a software as a service. I mean, Gmail is not giving us any opportunity to develop on top of the Gmail platform. Google Earth, it's not the answer. All the above mentioned, no. So why I'm saying the people who developed with these things, Google Maps is the platform as a service. For if you take an example of this Pick Me and Uber apps, so they developed on top of the Google Maps platform. So that's why we are selecting it as a PaaS offering. Gmail, it's just a service. Gmail is a software as a service thing. It's not all of the above. Google Earth is also software as a service. So Google Maps is a platform. And the next question, it's asking which is not a characteristic of SaaS? Multi-device support, web access, one-to-many, and the offline access. I got 15 out of 16, so I'm going to close this session. So if you see, someone said multi-device support, one-to-many, and the first thing that you have to notice is software as a service is a cloud service provided by a cloud vendor. So obviously you can't access this if you don't have internet. So not a characteristic. Offline access, we can't use SaaS as an offline access thing. You can't use Gmail, you can't use any of these software as a service based applications which is hosted in cloud if you don't have internet. So the answer is offline access. It's asking, it's about these compliance requirements. Something is a US federal law that regulates patient protected health information. Is it CSA, MTCS, HIPAA, or GDPR? HIPAA is the US federal law that regulates patient protected information. So from the name it says health information related compliance requirement. So it's not GDPR. GDPR is for this geo-fencing related. I mean, when you comply with GDPR, it says if you are within the European Union, you can't move your data outside the European Union location, but it's not related to any of this health information thing. The answer is HIPAA. So that's all for the session. So I hope you got the basic idea of these cloud related techniques.